academic and scientific part I am going to share with you. I would like to acknowledge my students. These are the that's उस पर नहीं काम करेगा. Okay. Right. Okay. So these are the farmer students who have earned their PhD under my supervision, and these are the current students. So before going to the specific topic, I would like to share some common slides for basically for the students. You see, science is the eye of everyone. One who has not got it is like a blind. So this is the, in general, holistic importance of the science in day-to-day life. And one can imagine who is not having the eye to see the natural world. Further, how science is defined? Science could not grow by itself. It needs the honest, dedicated, and devoted workers. And not only that, for the growth of science, it's highly desirable and demanding that more and more young minds opt science as a career for the benefit of the humanity and society. Not only that, science has done a lot of things for the humanity and society. One of the major things is that science is the only discipline among the other areas, including engineering, that's also a part of science, medical science, agricultural science, natural science, life sciences. It is the only branch who correct itself with the due course of the time. If any theorem or concept becomes obsolete with due course of time, then it has been discarded by the humanity and society. And new theory or new concepts comes into the existence. So finally, better things for better living through chemistry in general, but in particularly by organic chemistry. So you see what has science done in general? First, improvement of the quality of life, as we all know, in terms of food, health, transport, information, reasoning, as well as understanding. You see, in every area of the day-to-day life, what is the importance of science? How it has played a vital role among all the sectors. And particularly, chemistry has done a significant contribution. Either you talk about food, health, transport, information, reasoning, as well as understanding. Next, the most important thing about the science is that science is a means of avoiding prejudice in solving problems with reasoning. There were so many prejudices in our society. Of course, some of them are still existing. But science is the only discipline which can avoid those prejudices through scientific reason, logical reasons. So next, this is as we have seen, science has been broadened in numerous, many disciplines. For example, natural sciences, biological sciences, life sciences, earth sciences, medical sciences, engineering sciences, agricultural science, so many. So if you see the chemical sciences, Again, chemical sciences, for the sake of the convenience, has been organic chemistry, inorganic chemistry, physical chemistry, analytical chemistry, biological chemistry, industrial chemistry, material, so many. So, just you see the vitality of that particular branch. So, what is the chemistry? You see, chemistry is an old subject, maybe around 1000 BC. Modern chemistry and Lavoisier is subject to father of the modern chemistry, around 260 years old. But you see the life of the span of the organic synthesis is about 150 years old only. And during over this period, what kind of very value added contribution has been made by the organic chemistry in the society. So, like all sciences, chemistry has a unique place in our pattern of understanding the natural, our nature, or this globe. That's why chemistry is also, or chemical sciences is also known as mother science. If you see a spectrum, if one end of the spectrum occupying the life sciences, another end of the spectrum is occupying the mathematical sciences, in the center is the chemical science, particularly chemistry. On one hand, with the life sciences, it coordinates and uncovers the mystery of the life. And on the other hand, it coordinates with the mathematical sciences and discloses the mystery of the universe. So you see the importance of the chemistry. Now we are coming to the organic chemistry. In the periodic table, you see there are approximately around 130 elements, 130 element, that is the carbon. And you see, rest of the 129 elements responsible for only 1 million of the chemical species compounds. So, what is the speciality? What is the peculiarity of the carbon element? Either you see in the periodic table, either on the right side of the carbon or left side of the carbon or below the carbon, carbon, silicon, germanium 10. Just you see, below the carbon in the period is the silicon. But no other element is capable of making such a huge amount of compounds. Only carbon is the element in the periodic table which can make and making huge number of enormous, but that is the only peculiarity, speciality of the carbon element which can make bonding with itself or with any other element of the periodic table. No other element is there in the periodic table which can make a huge number of, and that property is known as catenation. That is the propensity for limitless bonding in a cyclic fashion with any other element of the periodic table. Means that is the unique property of the carbon. So, if we go the compounds, for the sake of the convenience of the study, you see, organic compounds, or you can say chemical species, broadly have been classified by the UPAC system into two. And if you talk about hydrocarbons, saturated hydrocarbons and unsaturated hydrocarbons, only two categories. Saturated hydrocarbons, you say alkanes. Again, alkanes, for the sake of the convenience, it could be straight chain, branch chain, maybe cyclic system. And if you go for the unsaturated hydrocarbons, again, two types of hydrocarbons, alkenes and alkynes, having double bond and triple bond. And you know the nature of the compound tells about the chemical reactivity of that system. For example, if we talk about the reactivity of the alkanes, only substitution reactions are possible in the case of alkanes. Saturated system, as you know, carbon is always tetravalent. Its valence is 4. So only substitution. Similarly, in the case of unsaturated system, either alkenes or alkynes, that is only addition reactions, no other. And again, based on the functional groups, as we know, in any chemical species, functional groups are the sites of the chemical reactivity. And you say the major functional groups, that is the alcohols, ether, amines, carbonyl compounds, and again carbonyl compounds, as you know, ketones, aldehyde, ester, amides, ether, so on. So this is the rough summary of the classification of the organic compounds, how they have been classified, and how their chemical reactivity can be defined. So as I told, this organic synthesis is roughly around 150-60 years old. As we know, the first synthesis in the laboratory have been done in the year 1828 by Frederick Wöhler. Now you see that what I told, that science is the only discipline which corrects itself with due course of time based on the requirement need of the humanity and society. Before the discovery of the urea, that Berzelius for the first time defined the chemical species into 2 categories. This was the history of the chemistry. Only 2 kinds of chemical species compounds, organic and inorganic. So Berzelius defined organic compounds means those compounds which have some vital connectivity, means derived from the living organism. So that termed as organic compounds, and those compounds which have no connectivity with the vitalism or which has been derived from the non-living things termed as inorganic compounds. Only 2 classes of chemical species, organic and inorganic. But Wöhler, you see, was the Berzelius student. Wöhler earned his PhD under the guidance of the Berzelius. In 1828, Wöhler was able to synthesize ammonium cyanate. His objective was to synthesize ammonium cyanate for some other purpose. Starting with both starting materials, you see, silver cyanate and ammonium chloride, both are pure inorganic compounds. Still, they are the inorganic compounds. But in spite of getting the ammonium cyanate, Wöhler got the urea, NH2CO, NH2. And that urea was same as the animal urine urea. And you know, urea is the organic compound. So a very well established concept in the realm of the chemical sciences, which was discovered or originated by the Berzelius, that what are the organic compounds and what are the inorganic compounds. His students only, Wöhler, abolished this concept and told that no, this is not the correct. It does not mean that organic compounds might be derived from the living species. One of the very well established in the chemical community concept was only. If you see the ammonium cyanate, this is the molecular formula. Ammonium cyanate, ammonium fulminate, and urea, all are different compounds having the same molecular formula. That is known as the isomerism. So, you see, this is the beauty of the science, beauty of the chemistry. Here I am talking only just for the sake of the students, maybe masters, UG or PhD students. If you understand some basic concepts, almost 99% problem of the chemical sciences, irrespective of the organic, inorganic, physical, analytical, material or any other branch, that is done. But the problem is that it's not mind experience observation. Chemistry, and in particularly organic chemistry, is one of the easiest subject among the natural sciences. No other subject is easier than the organic chemistry. Even I can say much more systematic, easier even than the mathematics. In mathematics, one can get maximum 100 out of 100. But in organic chemistry, one can get 110, 105 out of 100. That is the concept. But the thing is that one has to understand the basic concepts and fundamentals of the chemistry, of the science. Say, for example, that's why there are some terms. First is the four big carbons. Four big carbons. First carbon stands for composition. Means any material is there. Either you derive from the nature or you synthesize in the laboratory. The first job is that to know the composition of that thing. Means from which materials, from which elements, from which species that particular item or things or material has been composed of, has been made of. So first to know the composition. Say for example, if any compound is made up of carbon, hydrogen, nitrogen, oxygen, four elements, if you know that only four elements are there in that particular compound, the next job comes to the constitution. So second carbon stands for constitution. How these atoms are connected to each other. Carbon is connected to carbon, or hydrogen, or nitrogen, or oxygen. Nitrogen is connected, means connectivity. That's second carbon role. If one knows the constitution, how atoms are connected to each other, then the third carbon starts for the configuration. As you know, the configuration means three-dimensional structure in the space. What is the configuration of the molecule? And if configuration becomes known, then the fourth, that is the last carbon, stands for the conformation. What is the conformation? There is a major difference between configuration and conformation. As the term implies, conform. Here, whatever we are talking about chemistry, in particularly organic chemistry, that's around the bonds only. So conformation means just rotation about the single bond. If you rotate by 1 degree, the groups, atoms or substituents attached to a particular atom, their position is being changed in the space, three-dimensional space, having different conformation. Configuration means no, it has nothing to take with the rotation. If one wish to transform, change one configuration to another configuration, one has to first break a bond and then make a bond. So this is the difference between configuration and conformation. So you see what is the role of the four big carbons, that is the composition, constitution, configuration and conformation. Next thing is reactions. Again, I am taking these are the very common things, irrespective of the inorganic, physical, organic, analytical, material, nuclear, or any kind of chemistry. In the chemical sciences, there are only three kinds of reactions. Major, only three. If one is able to discover the fourth category of the reaction, that is a very hot area for the Nobel Prize. Till that, only three. First is known as polar reactions. Second is free radical reactions. And third category is the pericyclic reactions. Only broad category of the reactions. No fourth category of the reaction exists. Polar reactions, free radical reactions, and pericyclic reactions. Whatever I told in the beginning that this is the damn easy subject. One has to understand the basic concepts and fundamentals. And to know the chemical sciences, particularly chemistry, there is no quantum jump. One has to move step by step. There is no quantum jump, energy level first to fourth or fifth or homo to lumo or lumo to sumo, nothing like that. So, you see, as the name implies, again I am requesting just to the students, organic chemistry, if you are going to cram, this is the highly reversible reaction. Your rate of forgetting will be millions times faster than the rate of cramming. अगर रटने का प्रयास करेंगे तो आप देखिए अपने लाइफ में आप महसूस किए होंगे, बहुत सारी चीजें आप पढ़ते हैं, एग्जामिनेशन के समय आप रटते हैं, रात भर जग करके पढ़ते हैं, और एक हफ्ते बाद, 2 हफ्ते बाद, 1 महीने बाद, डिपेंडिंग अपॉन द मेमोरी ऑफ ए पर्टिकुलर इंडिविजुअल, आप कहते हैं कि नहीं याद, भूल गया, पढ़ा था भूल गया. So try to understand the basic concepts. Polar reactions, as the name implies, reactions involving polar species. And you know, only 2 types of polar species is there. One is the electron rich, another is the electron poor. No third type of species is there. And these 2 species, depending upon the condition of the reactions, have been termed as nucleophile, electrophile, Lewis acid, Lewis base, Bronsted acid, Bronsted base, whatever you call. Both are electron rich and electron poor. So, polar reactions means reactions involving polar species. Again, since this is the broad category of the reactions, for the sake of the convenience of the study, again polar reactions have been classified into substitution, elimination, addition, rearrangement, so on. And again, as your name implies, additions means something is being added to something. So, for example, if you are talking about the reactivity of the unsaturated hydrocarbons, alkenes and alkynes, only additions are possible. In the case of alkenes, elimination is also possible, which would lead to the alkynes. You cannot eliminate the alkynes. So, only these are the subclasses. Again, if you say in the case of substitution reaction, nucleophilic substitution, electrophilic substitution, again nucleophilic substitution, SN1, SN2, SNI, SN2 prime, SN1 prime. So broadly only three categories. In the same way, second is the free radical, as the name implies, reactions involving free radicals. Only free radicals. It again could be the substitution, addition, elimination, rearrangement, which involve the free radical as the intermediate or transition states. And third category is the pericyclic. Again, as the name implies, pericyclic. Since we are talking about the kinds of the reactions, what does it mean? It means that reactions means involvement, interaction of the electrons, of the bonds, breaking or making of the bonds. And you know, bonds means electrons. You know what is the site of the electrons? Orbital. So again, as the pericyclic means there is no free radical, no polar species, simply cyclic reorganization of the electron into the system. No transition states or intermediates, maybe very transient species. Cyclic reorganization of the electrons into the system. Again, for the sake of the convenience, these pericyclic reactions have been subclassified: cycloaddition, electrocyclic, pericyclic, chelitropic, in reaction, sigmatropic. These are the subclassification because branch is so wide. So nothing to cram. One has to understand the basic concepts. Can I know how many students are master students here, please? Can you raise your hands? Master students. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's good. PhD students? Yeah, almost. That's good. As I told, only two kinds of species are there. Here, species means not human kind of species. I am talking about the chemical species. Whatever we are discussing about the chemistry. For only master's students, just I want to know the basic understanding of the chemistry. You might have heard several times nucleophiles and base. आपने सुना है ना? हम एमएससी स्टूडेंट से बात कर रहे हैं. आपने सुना है कि नहीं? बेस एंड न्यूक्लियोफाइल. अरे भाई हाँ या ना बोलो आप. यस नो. बहुत बार सुने होंगे या पढ़े भी हैं. सो बोथ आर द सेम आर डिफरेंट. न्यूक्लियोफाइल एंड बेस फॉर एमएससी स्टूडेंट्स. देखिए, समय को हम लोग बर्बाद न करें. दैट इज द वन ऑफ द मोस्ट इंपॉर्टेंट थिंग इन द नेचर इन द लाइफ. इफ वी आर नॉट गोइंग टू वैल्यू द टाइम, टाइम इज नॉट गोइंग टू वैल्यू अस. कीप इन माइंड. अगर नहीं है तो बताइए नो, ताकि हम लोग कुछ शेयर कर सके. इफ यू नो देन प्लीज लेट अस नो. या सम टाइम बोथ आर सेम. आप हमारा क्वेश्चन समझे हैं ना? न्यूक्लियोफाइल एंड बेस both are the electron rich species. Both are the electron rich species. My question is, both are same or different? Both are same. Then why there is the two names? One should be deleted by the UPAC. भाई UPAC तो यही कहता है ना? For the simplicity, for the nomenclature of the compounds. अब बैठो बेटा. एनीवन? इन्होंने कहा दोनों सेम है, लेकिन बोथ आर नॉट सेम.
Sometimes same.
एनीवन? या प्लीज. जी नहीं आई एम टॉकिंग अबाउट न्यूक्लियोफाइल एंड बेस. हाँ हाँ आप बताइए.
सर दोनों इलेक्ट्रॉन पेयर होता है, वो न्यूक्लियस लविंग होता है, ये होता है प्रोटॉन लविंग सर, बेस जो होता है
इलेक्ट्रॉन लविंग और नहीं, यू आर कमिंग क्लोजर टू द आंसर.
इलेक्ट्रॉन लविंग न्यूक्लियोफाइल होता है और बेस जो होता है प्रोटॉन एक्सेप्टेंस होता है. दैट्स
इलेक्ट्रॉन लविंग कहाँ से? न्यूक्लियोफाइल इज द ऑलरेडी इलेक्ट्रॉन रिच स्पीशीज. बैठिए बट हाँ, एनीवन?
Good morning, sir.
Yeah.
A nucleophile, that is the group of atoms and the molecules containing electron rich, and now it's having a felicity to attack the attack the carbon positive charge.
Only carbon positive.
Carbon positive charge.
And what about
And,
base?
Pardon?
What about base?
Base. Base. That is there are different kind of base. Non-hydroxyl bases also are there.
Say for example, I am.
So base will.
I am making it more specific. Say for example, take the hydroxide ion OH minus.
जी.
What is this OH minus?
Hydroxyl ion.
No.
Hydroxide ion.
It's a nucleophile or base?
It's base.
Not nucleophile.
जी no.
Oh my God. Hydroxide ion is a nucleophile also.
But
Well established nucleophilic reactions. Okay. Yeah, please. Just I wanted to know about the understanding of the basic concepts and fundamentals so that I can share with my whatever the little knowledge I have to that level only. Don't take it otherwise. As I told, both are the electron-rich species, nucleophile as well as base. If any electron-rich species coordinating, attacking, making a bond with the proton, then at that time that is known as acting as a base. Otherwise, nucleophile, any electrophilic center, it could be carbon, nitrogen, sulfur, oxygen, any element of the periodic table. If any electron-rich species attacks a proton, then it acts as a base, otherwise nucleophile. अब बताइए इसमें ऐसी कौन कॉम्प्लेक्सिटी है जो आप समझ में नहीं आ रहा है? अगर आप समझ गए तो आप एक हफ्ते बाद, एक महीने बाद, एक साल बाद भूल जाते हैं. You are not going to forget your names, your parents' names, your village names, are the things in this mortal world which you love very much. But we are talking about subject. हाँ सर मैंने पढ़ा है, बहुत बार पढ़ा है, लेकिन मैं भूल गया. So it reflects that you are not going through the proper understanding. Similarly, types of carbon. Only 3 types of carbon. In terms of hybridization, sp3, sp2 and sp. No 4th kinds of hybridization. Only 3. And in terms of primary, secondary, tertiary and quaternary, 4 kinds of carbon. These 4 kinds of carbon you can define in terms of carbon or in terms of hydrogen also. Primary carbon means carbon attached with 3 hydrogen. Secondary carbon, carbon attached with 2 hydrogen. Tertiary carbon, carbon attached with only 1 hydrogen. And quaternary carbon means no hydrogen. Carbon is bonded with 4 carbons. Similarly, types of bonds. You see in the whole chemical sciences, only 2 kinds of bonds are there. Sigma bond and pi bond. No. यदि आप कोई 3rd टाइप का बॉन्ड डिस्कवर कर दे, अगेन ए वेरी ब्रांड एरिया फॉर द नोबेल प्राइज इन केमिकल साइंसेस. Only sigma and pi bond. And you know how sigma bond is formed and how pi bond is going to form. Again, if you talk in terms of sigma and pi bonds, only three kinds of bonds: single bond, double bond, triple bond. Is there any compound which is having quadruple bond, means four bonded? No, no chemical species. If coordinate bonding is also there in the organometallic compounds or complexes or coordinate compounds, after making the coordination, if that species comes into existence, it becomes the covalent bond. So, if single bond is there, it means that is the only sigma bond. If double bond is there, it means one sigma bond and another pi bond. And if triple bond is there, it means middle one is the sigma bond and two pi bonds, and both pi bonds in the case of triple bond are orthogonal to each other, perpendicular to each other. You know how the two pi bonds are going to form. Next is the molecular orbitals. Again you see bonding, non-bonding and anti-bonding. No fourth kind of the molecular orbitals. And the name already implied: bonding molecular orbitals, non-bonding molecular orbitals, and anti-bonding molecular orbitals. And you know, means bonds are being formed by the hybridization, by the overlap of the molecular orbitals only. And reactive species, only two. That is the intermediates and transition species. Again, intermediates have been broadly classified into three major intermediates: carbocations, carbanions, and free radicals. These are the major, which are very frequently involved into chemical reactions. But apart from these, there are carbene, nitrines, benzines, so many other intermediates are also there. And transition states, as you know, what is the again major difference between the intermediates and transition states? Intermediates one can trap, one can isolate, one can characterize. But transition states are the very high energy species, highly unstable. It cannot be isolated. It could be only theoretically defined and it could be only imagined. Energy can be calculated by the involvement of the deep theoreticians. Again, systems, if you talk about the systems, two kinds of major systems: cyclic system and acyclic system. Either you talk the organic compounds, inorganic compounds, or any kind of material, kinds of system, cyclic and acyclic. Again, cyclic system have been subclassified because you see, as a species are numerous, huge amount of. So कार्बोसाइक्लिक एंड हेटेरोसाइक्लिक. अगेन यू सी, देखिए मैं बार बार आपसे कह रहा हूं कि ऑर्गेनिक केमिस्ट्री रटने की चीज बिल्कुल नहीं है. जिस दिन आप रटना शुरू करेंगे उसी दिन से ऑर्गेनिक केमिस्ट्री आपको भूलना शुरू हो जाएगा, कुछ भी समझ में नहीं आएगा. As the name implies, you try to, it's very much sufficient in itself. Carbocyclic, cyclic system made up of only carbon. Heterocyclic means cyclic system which includes any other element of the periodic table. You take any element, either main group metal, transition metal, that comes under the purview of the heterocycles. But most common heterocyclic systems involve the heteroatom, nitrogen, oxygen, sulfur, selenium, tellurium. These are the common, phosphorus. These are the common heteroatoms which compounds have been huge number of synthesized and studied. So if you talk the system in terms of stability, again you see aromatic system, non-aromatic system and anti-aromatic system. That is the in terms of stability of the system. And this order is in the decreasing order. Aromatic system are the most stable system. Anti-aromatic system are the least stable system. Non-aromatic system exist in between both. And that stability here means in terms of energy. Processes, as I discussed, only two kinds of processes, bond making and bond breaking. No third category is there. In the same way, catalysts, only two major classes of catalysts, hetero and homo. Either you say it, organocatalyst, tungsten metal catalyst, means there are again subdivision. Structures, as I told in the beginning, conformation and configuration. Factors affecting the reactions, any reactions, only two factors are there. That is the electronic and steric factor. And in electronic, as I discussed, only two kinds of species, electron donating and electron withdrawing. No third. So, the solvents, as I discussed, only polar solvent and non-polar solvents, protic and aprotic. Again by permutation and combination, polar aprotic, polar protic, apolar non, there are some. Just for the sake of the convenience only. And finally, the position of the electrons, which is mainly responsible for all kinds of chemistry. So, you know, the electrons, house, home, or residence in the space is the orbitals. And only two kinds of location. Either electrons could be localized or delocalized. Again, you see the same local and vocal, local and global. Localized means electrons are centered at a particular center, particular atom, particular site. Delocalized means spread over more than one centers. So, you see, these are the basic concepts. If one understands very well, almost more than 90% job of the chemical sciences has been done. So now I am coming to my research area. What kind of research? Just I am going to give just a flavor of the kinds of chemistry we are doing at Banaras Hindu University. As we discuss, the functional groups are the sites of the reactivity. Functional groups, as we discussed, nitro, amines, carbonyl could be aldehyde, ketone, ester, amide, any kind. If a compound, say for example, acetophenone, is containing only one functional group, that is the ketone. So, it will give the reactions of the ketones only. In a polyfunctional molecule means molecule having more than one functional group. Maybe 2, 3, 4 in the simple molecule. Say for example, if you talk about esters, esters are having two functional groups, keto group and ether group. Both are coming together, that is the ester. Say for example, amide, CO and amino group. So, if a compound is having more than one functional groups and all the functional groups are situated very close to each other, not very far. Say for example, if you take a long chain compounds having one in the amino group, another alcohol, then this compounds, and in between there are, say for example, 8, 9, 10 carbon atoms, then this compound is going to the specific reaction of the amino group and specific reactions of the alcohol. But if the functional groups are spaced very closely, then apart from their individual chemical reactivity, they show some unusual, unexpected behavior and that behavior is due to the identity and interconnectedness of the molecule. Means say unusual chemistry, and to this end our molecule is say very simple molecule, beta-keto dithioester. Our chemistry is very much focused, highly focused. The center of our chemistry is this molecule only. You see, this is in the case of beta-keto dithioester, if you compare with the ester molecule, beta-keto ester, which chemistry is very widely studied. Two oxygens have been replaced with the sulfur atom. That becomes beta-keto dithioesters. So now you see, in this molecule, one is group is the carbonyl group, another functional group is the C double bond S, that is the thiocarbonyl, and then another is the thioether. Three basic functional groups, and these three basic groups show the chemical and physical properties of these functionality. Apart from these, they show some unusual reactivity. So you see, this simple molecule is having three nucleophilic centers, that is the oxygen, alpha carbon, and sulfur. These are the three nucleophiles, and two electrophilic centers, carbonyl carbon and thiocarbonyl carbon. So you see, this very small molecules, simple dithioderivative of the beta-keto ester, is having many functional groups, 6-7 functional groups, and that shows the unusual reactivity, unusual behavior, unexpected chemistry. Molecule looks very simple, but if in this simple molecule there are 6-7 functional groups, and out of these functional groups, if there are more than one nucleophilic centers, more than one electrophilic centers, then it becomes very tough to control the reactivity. Which center? Now you see here, if that becomes enol, means this CH2 alpha carbon, that pointer is not working, you see, that is the beta-keto alpha is the CH2 group, alpha methylene. So this CH2, this alpha, both carbons are, it becomes enol. If it moves towards, it becomes enthiol. You see something like that in the below structure. And carbonyl is there, thiocarbonyl is there, thioester is there. So it becomes 6-7 functional. So the major problems comes how to control the reactivity, and particularly how to control the selectivity. Because two things are very, very important in the reactions again. Selectivity, again, only this is the simple molecule, and that is the enormous kind of reactions can be carried out. So our vision of the reaction is that our all reactions are one part reaction. One part, whatever the, and one of the reagent is thioesters or its derivative thioamide. And reactions are highly sustainable. Most of the reactions have been carried out at room temperature. So you see, just I am giving a flavor Starting with this simple beta-keto dithioester, just you name any heterocycles, either 5-membered or 6-membered or fused heterocycles, we have been able to synthesize almost all kinds of the general heterocycles containing nitrogen, oxygen, sulfur in different permutation and combinations. And you see the kind of publications our group is being able to done, starting with this very simple molecule. That's it can be synthesized anywhere in the laboratory, and molecule is very much bench stable. You may be wondering that this is the sulfur containing compound, so maybe foul or very bad smelling. No, not at all. It has no foul smell. Only the precaution is required during the time of the synthesis, because it needs carbon disulfide or some other sulfur containing carbonates. So you need a fuming only. After the formation of the dithioesters or thioamides, highly bench stable, having no bad smell. So you see, this is the simple reaction of dithioesters. You see our compounds. That is the synthesizer of benzo-1,3-thiazine in one part. You see the simplicity of the reaction. Means one part, no catalyst, no metal, reaction has been carried out at room temperature, and solvent is the polar aprotic, that is the acetonitrile. This is the simple mechanism of the reactions. We have done just to establish the mechanism course of the reaction, how our reactions is proceeding. Students are doing control experiments, then we are able to synthesize and form reactions. And this is the again application of the reactions. Our reactions are gram scalable, and that is the further transformation, derivatization of the synthesized heterocycles. And we are able to have the single crystal also, and that helps us to derive the final structure, absolute three-dimensional structure of the molecule. Again, this is the simply generality of the reaction. We have synthesized a huge number of compounds containing all kinds of the substituents, aromatic, heteroaromatic, that is the heterocyclics, and bulky groups like naphthyl, biphenyl, extended aromatics, alkyls, all kinds of substituents are being tolerated with the system. You see again, this is the dithioesters. We have derivatized the dithioesters to the S-allyl derivative, and this S-allyl derivative simply by hitting at 80 degree at the solvents give the very important, that is the thiophene. And as we know, this is the 2+2. This is the conventional how intermolecular and intramolecular, that is the well established reaction. And in our case, again, we have done the same. We have utilized the same concept, that is the 2+2 cycloaddition. This is the again single crystal structure of the synthesized molecule. These are the different kinds of substrate scope. Again, these are the control experiments which defines our mechanism by energy calculations of the different transition states and intermediates involved during the course of the reaction. And this is the further derivatization and scale-up reaction. We have carried out our almost of the reaction to the gram level also. Similarly, you see, this is the, you will find in each and every reaction, one of our starting materials is dithioesters or its derivative thioamide. You see, starting from this simple thioamides, and that is alpha melanonitrile, you see the formation of cyclic fused heterocyclic system. Otherwise, really, it's very difficult, very difficult to synthesize. And you see the condition of the reaction. Again, at room temperature. Time of the reaction is also not very high, means 24 hours, 1 day, 2 day, week, something like that. And you see the condition, that is the means involving no toxic reagent, toxic substrates, are very complex isolation. So you see the sustainability and greenness of the reaction. Again, this is the simple generality and substrate scope. This is the gram scale synthesis and further derivatization of the reaction. And this is the, again, control experiments. And based on the control experiments and our experimental observations, this is the simple organic chemistry mechanism. And finally, we are going to have the fused heterocyclic system. And in our most of the reactions, we have trapped the intermediates at transition state formed during the course of the reaction, through which reaction proceeds by HRMS study. Again, you see this reaction, you see the kind of starting materials involved, and you please note the condition of the reaction. You see simple cesium carbonate base. Again, room temperature 3 to 5 air, open air, no glow box. Because you see, if one is using the transition metal catalyst, for example, ruthenium, rhodium, palladium, then very inert dry condition is being needed. And for that, you need the glow box. And you might be aware that the cost of the glow box, a common general glow box, around 50 lakhs. So you see what is the simplicity of our reactions. Again, this is the simply generality of the reaction, how general is our reactions. Again, the gram stability, some control experiment, and further derivatization of the products. And based on this is the product mechanism. Just you see, in all cases, our reactions are highly selective. And on this, it looks very easy, but for optimization of the reaction, students have to carry out more than sometimes 200 sets of reactions for getting the optimal condition for that particular reactions. So it's not very easy, but simply it's like to see here. Again, you see, one of the substrate is dithioesters and thioamides. We are able to again synthesize a very important class of heterocycles, that is the highly substituted thiophene derivatives. Again, this is the simple mechanism. And you see here also, means whatever the starting materials are there, very easy accessibility is there, easily available. Either you can synthesize starting with the very easily available chemicals, substrates, and synthesis is also very easy, and you see the kind of final molecule is going to be formed. That is just, you see, thiadiazine, 6-membered ring containing 1 sulfur atom and 2 nitrogen atom in one part. That's otherwise very, very tough, very difficult. Again, this is the simple mechanism. How, and you see, everywhere selectivity is there. Again, you see the next class of this, I am giving the flavor. What kind of chemistry we are doing. You see, simply you might not be interested very much, but you see, here, they are the flavors of our kinds of chemistry we are doing at Banaras Hindu University. You see, simple dithioesters and simple, you see, 1 to 5 membered ring containing 2 sulfur atoms in one part. And you see the condition of the reaction again, simple potassium phosphate, DMF solvent, room temperature, open air, and 1,2-dithiol 5 containing two sulfur atoms. Otherwise, really, it's very, very tough to make the sulfur-sulfur bond or carbon-sulfur bond in one part reaction. So this is again a simple mechanism. Here again, you see our dithioesters in the enolic form. No catalyst, no metal, simple potassium carbonate, dioxane, room temperature, open air. And again, in most of the cases, we have got the single crystals to stabilize the structure of the targeted molecule. Again, you see our dithioesters, we have derivatized hydroxy amino compound. Alpha methylene group has been converted into the hydroxy amino, that is the oxime derivative. And then this is treated with Su by variation of the simple haloamines. We are getting the 5-membered and 6-membered heterocycles. Again, this is the mechanism, and this is the simple crystal structure. Again, you see thioamides and simple sulfaldehyde. Formation of, that is the chromines, substituted chromines. And you know how important biologically and chromine is how much important for the point of medicinal chemistry and pharmaceuticals. Again, this is the allyl derivative of our dithioesters. This you please keep mind on the reaction, condition of the reaction. DMSO, room temperature, open air. No high temperature is required. Same way, this is the scope, mechanism, and again, this is the simple, this is the hydrogen. We have converted CH2 into the hydrogen derivative. Then this is the electrochemistry. It's very green chemistry. And in this case, the beauty of this case is that we do not need the flash or column chromatography for the purification or isolation of the compounds. Simply by crystallization with the co-solvents, ethyl acetate and N-hexane in different molar ratios, we have, again you see this, that is the combination of the, this is the catalytic reaction, ruthenium plus photo. And this you see the kind of heterocycles. 5-membered ring containing 2 nitrogen and 1 sulfur. And not only that, containing exocyclic amino group. So you see the functionality. This molecule again highly functional molecules which can be further derivatized into a variety of value-added molecules. So this is the simple mechanism. This is again gram scalability and further derivatization of our synthesized molecule, oxidation, reduction. So you see, what does it mean in organic synthesis? What are the important factors? First factor, that your any reaction should be cost effective. It should not involve the highly expensive starting materials or reagents. So our all reactions are highly cost effective. We are getting the very excellent yield in most of the cases, almost quantitative yield, because our reactions are one part atom economy and cost economy also. Means in most of the cases no byproducts. All the starting materials are being involved into the final target molecule. Rate of the reactions is very fast, highly efficient reactions. Within hours, most of the reaction within minutes. And isolation and purification of the products, very simple. Of course, it needs column chromatography, but not very sophisticated isolation. Eco-friendly means no toxic substrate or reagents are being involved during the course of the reaction, and operationally very simple. One can do at the BSc laboratory. It needs only one stirrer, nothing else. So highlights of our all reactions, you see, our reactions are cheap and easily accessible available starting materials. Operationally simple one part cascade reactions, and you see here cascade reactions means in the single part only, there are several steps, maybe 3 steps, 4 steps, 5 steps. Bond breaking, bond formation simultaneous, concomitantly. If one bond is bound, carbon-carbon is breaking, carbon-nitrogen forming, carbon-sulfur bonding. So, most of the reactions are part atom and step economy protocol. Most of the cases, very clean reactions. Single spot on the TLC. Very clean reaction. Normally under open air, no inert atmosphere, means no need of the nitrogen gas or helium gas or something like that. Easy isolation and purification procedures. Good to excellent yields. Most of the cases quantitative, more than 90% yields we are getting. High selectivity. Most of the reactions are our chemo and radioselective. Because you see, this simple molecule is having many functional sites. 3, 4 nucleophilic centers, 2, 3 electrophilic centers. High selectivity, I told, wide substrate scope, scalable reaction, and synthetic applications, and further downstream transformation in it. So, you see, chemistry scope is still unlimited. Surprises all the time. Even you do the known reactions, there is the possibility of the serendipity. This is the beauty of the chemistry. Because a little bit change of the condition, either temperature or molar ratio of the reagent or pressure or atmosphere, course of the reaction may change. The way you do the chemistry and the chemistry we do are both are very fast changing. And really, this is the practically true. We are the chemists only who will integrate the whole science. No other. So, what is the future challenge for the chemical sciences? You see, organic synthesis has already made a great contribution to the development of biological and material sciences. We actually expect an increase of its importance. On the other hand, for a sustainable future society, it is necessary to redirect the traditional chemical industry toward one that is environmentally acceptable, that is the means green and clean and in harmony with the society. You see, our today most of the industry, there are the highly lethal byproducts are being formed. Either you talk about metal industry, means aluminum, steel, iron, or leather industry, or means any industry. So this is the responsibility of the synthetic organic chemists to do better for the better life of the humanity. So you see, uncontrolled and excessive human activities are triggering drastic climate fluctuations and environmental changes, depleting resources and energy, widening the north-south gap, and leading our human society to a highly critical or crisis situation. So these are all the problems that we have created, not nature have created. All the problems we have created, but no one is willing to take the responsibility for resolving facing manifold challenges, many of which were created in part or in whole by humans. Chemists need to broaden their prospects and multidisciplinary undertakings. Science and technology are essential to solve environmental crisis. We need scientists who will not only be capable of implementing the most advanced research or innovation, but who can also serve as leaders in our future society. That is the more important thing, because now you see, whatever the policies for the sake of the society or humanity are being framed or made, at this public platform, I am not going to share. You all know. Just you see the background and educational qualifications of our leads. So, vibrant science needed for future society. So you see, just by one example, I am going to share how we think is more important than what is present. Uh, this is the uh, just spec cover, but just like this is the nine highest one digit integer. That's a true highest single integer 9. But it can be viewed, it can be seen by different ways. 9 is lucky number for some people. 7 plus 2 is equal to 9. 10 minus 1 is also 9. 3 into 3 is also 9. 18 divided by 2 is also 9. 3 square is also 9. And under root 81 is also 9. Means you see several ways of viewing and the practical truth is that this is the highest single integer. But all the viewers are also correct. Under root 81 is equal to 9. That is the correct. Excuse me. 7 plus 2, 9 is also fine. 10 minus 1 is 9 is also fine. So I mean, how we realize, how we feel, how you are going to look the problem, that is the more important than the existing problem. Uh, if some of you have visited the Banaras University, this is our department of chemistry, that is the external view. And this is the, you see, one of the biggest department of the Asia in terms of faculty strength as well as students. Department is currently catering 3,000 students. Can you imagine in one department, including UG, PG, research scholars and postdoc? Just you means almost better than a little bit single institute. You see, most of the IITs are having roughly around maximum 2,000 students only. Our department is catering 3,000 students. So there are two big lawns. One is the outer lawn, and that is the inner lawn of the department. And this is the replica of the Kashi Vishwanath, that is the original temple, which is in the heart of the city. And this is the temple in the heart, in the center of the Banaras Hind University. That is the replica of the Kashi Vishwanath temple. And as you know, this Kashi or Banaras or Varanasi, that is the known as city of the moksha. And that is the known as in our ancient history one of the oldest city on the earth. That is the Kashi, that is the Varanasi, and that is the Banaras. As I know, most people not from the India, different parts of the India, even from the abroad, now coming at the last hours of their life to get the moksha in Varanasi. And as you know, that's why there are two cremation sites. One is the Mandkanika Ghat and another is the Harishan Ghat. And we believe that in our history, in our methods, in our logistics, one who is taking his last breath in Banaras directly goes to the heaven. That is gets the moksha. So these are the two ghats. And finally, I would like to thank you all for your patient hearing. And lastly, I would like to acknowledge the different funding agency, that is the DST, SCRB, which now have changed to ANRF, CSIR, UGC, UKRI, that is the international grants, and JCBOS National Fellowship and IOE BHU for the funding, for which you could be able to sustain, do some kinds of chemistry at the Banaras Hindu University Chemistry Department. So once again, thank you all very much. It would be my pleasure if you have any kind of query, any kind of confusion, or any kind of question. If I am able to clarify, I am able to justify, it would be my pleasure. Otherwise, I will say, frankly, I do not know. I have no hesitation in saying that I do not know.
Sir, first of all, thank you for such a great lecture. I am an inorganic chemist, so two questions came into my mind. Maybe they are silly, but
No.
just came. In one of your complexes, I have seen that there is a heterocycle with sulfur-sulfur bond inside the heterocycle. When we do inorganic reactions, we use superoxides or hydrogen. Those are fairly unstable. And as oxygen is sulfur is just beneath oxygen in the periodic table, I expect that sulfur-sulfur bond will also be equally unstable. But you have got a compound which is stable, because I have seen you have characterized these extensively.
We have got the single crystal also highly stable, because you see that of course sulfur bond is there, but if that sulfur bond not into only the cyclic system, in acyclic system you say the disulfides, very much stable.
But it is inside a cyclic system.
In cyclic system, that is simply 1,2 dithiols.
Okay.
There are 1,3 dithiols, because this is the heterocyclic system containing 2 heterosulfur atoms, and that is the 5-membered ring.
This is very much stable in room temperature.
Highly bench stable. You can keep the final compound for years.
Okay.
And the bench only. No problem.
So another question is that we have started a new course in our department as inorganic photochemistry, and in our PG courses also there is 1 or 2 units in 4th semester about inorganic photochemistry, where we teach the students about ruthenium based photochemistry, ruthenium 2 and ruthenium 3 based inorganic photochemistry. I have seen that there are few reactions. We have used ruthenium 2 as catalyst and put LED bulb. So have you gone through the mechanistic part of those?
Yes. Okay. We have done the theoretical calculation with the help of theoreticians also. But actually, please be seated. What I told the students in my group, I have free hand to students. Means not always my vision has to be implemented. My idea has to be implemented. If students something thinks, if you treat with the amines, you will get the amides. It's very simple. It's a very simple condition. The only thing is that during the synthesis of the dithioesters, you need a strong fuming cupboard so that the toxic, unavoidable gases can evolve.
कोई एमएससी स्टूडेंट कुछ पूछना चाहेगा? कोई भी?
ये फैकल्टी तो हमसे ज्यादा जानते हैं, ये हमसे ज्यादा तेज हैं. अगर आप में से कोई
ऑर्गेनिक का कोई क्वेश्चन जो आपको
नहीं कहीं से भी एनी ब्रांच ऑफ द केमिस्ट्री यदि मैं बता पाऊंगा तो it would be my pleasure. Otherwise, I would say very happily no.
थैंक यू सर. बोलो. हाँ बताएं.
ऑर्गेनिक केमिस्ट्री मतलब एनिमल्स वाले केमिस्ट्री से अलग हम लोग सिंथेसाइज भी कर सकते हैं. तो सर वो मतलब ये तो है, लेकिन सर ये कैसे है, थोड़ा सा हम ये समझना चाहते.
मतलब मैं नहीं समझ पाया
आप ऑर्गेनिक केमिस्ट्री सर मतलब लिविंग ऑर्गेनिज्म से रिलेटेड है
जी. नहीं अब नहीं है,
अब नहीं है सर. आपने कहा सर
जी, वही तो मैं कहा कि जो जब केमिस्ट्री की शुरुआत हुई इस वर्ल्ड में जी, तो फर्स्ट टाइम जो मैंने बताया बर्जिलियस, नोन एज द फादर ऑफ द केमिस्ट्री, बर्जिलियस ने केमिकल स्पीसीज को सिर्फ 2 कैटेगरी में क्वालिफाई किया, इनऑर्गेनिक एंड ऑर्गेनिक. और दिस कंसेप्ट was continued in the chemical community more than 100 years. उसी का स्टूडेंट बोलर जो उसके साथ पीएचडी किया, आप तो देखिए यह क्या चीज दर्शाता है कि पहले की केमिस्ट्री वाज द सेरेंडिपिटस. You see, most of the chemistry 100 years back, that was the serendipity. Means आप बनाना कुछ और चाहते हैं, लैब में बन जाता था कुछ और. पहले की केमिस्ट्री इंटायरली डिफरेंट थी आज के केमिस्ट्री से. आप नेचुरल प्रोडक्ट आइसोलेट कर लेते थे. पहले तो नेचुरल प्रोडक्ट केमिस्ट्री ही थी ना. आइसोलेट कर लेते थे नेचुरल सोर्सेस से. आइसोलेशन में आपको 1 दिन 2 दिन लगता था और उस कंपाउंड के कैरेक्टराइजेशन में सालों लग जाते थे. मोर देन 12 months. क्योंकि ना आपके पास एनएमआर था, ना एचआरएमएस था, ना एक्सआरडी था, ना इस तरह के हाई एंड इक्विपमेंट्स थे. तो उस समय का जो मेथड था, आपको उस कॉम्प्लेक्स मॉलिक्यूल को आप ब्रेक करते थे, छोटे छोटे सेगमेंट में तोड़ते थे, फिर उसको कैरेक्टराइज करते थे. दैट इज योर डिट्रोसिंथेसिस. बट आज की केमिस्ट्री इज इंटायरली डिफरेंट, टारगेटेड. अगर आपको पैरासीटामॉल सिंथेसाइज करना है तो सिर्फ पैरासीटामॉल ही आप बनाएंगे. विटामिन बी है तो विटामिन बी बनेगी, विटामिन सी है तो कोई एंटीबायोटिक. अगर एंथ्रोमाइसिन सिंथेसाइज करना है तो एंथ्रोमाइसिन. पहले ऐसा नहीं था. सो अब वो कंसेप्ट नहीं रहा. तो वोलर ने तो उस कंसेप्ट को चेंज कर दिया कि नाउ देयर इज नो इनऑर्गेनिक और ब्रॉडली ऑर्गेनिक व्हिच कैन बी हैविंग द वाइटल कनेक्टिविटी और समथिंग लाइक दैट. ऐसा कुछ नहीं रहा. इनऑर्गेनिक से देखिए बहुत सारे जो टारगेटेड कंपाउंड्स हैं वो ऑर्गेनिक कंपाउंड्स हैं. जी
थैंक यू सर. प्रणाम सर.
सर एक क्वेरीज था मेरे रिसर्च. जब न्यूक्लियोफाइल एंड बेस के बारे में जब हम लोग का डिस्कशन चल रही थी सर, तो जहाँ तक मेरा एक डाउट आ रहा था कि जो फिलिसिटी को लेकर के हम रिलेट करते हैं न्यूक्लियोफिलिसिटी एंड बेसिसिटी, तो वहाँ पर दोनों में कुछ ना कुछ तो काइनेटिक एंड थर्मोकाइनेटिक प्रॉपर्टी का डिफरेंस है. दैट्स द मेजर लार्ज डिफरेंस बिटवीन द न्यूक्लियोफिलिसिटी एंड बेसिसिटी. So how could I distinguish that, sir? Nucleophilicity will have the kinetic property and basicity will have the thermal kinetic property. जी.
That control is also important. मैं सिंपल बता रहा था कि how nucleophile. I think you are able to hear. Oh. Okay. Yeah. I was simply saying either nucleophile or base or nucleophilicity or basicity, how they are different. So whatever you told, that there is the thermodynamic control and kinetic control. In the case of nucleophilicity, there is the kinetic control parameter, and in the case of basicity, there is the thermodynamic control parameter. I guess you might be following the what is the thermodynamic control and kinetic control.
That thing. Yes,
Yeah.
sir. Yes.
That's good.
Thank you.
थैंक यू सर. सर का आज जो हम लोग ने लेक्चर सुना वो हमको 15 साल पहले ले गया. जब सर गोरखपुर यूनिवर्सिटी में टीचिंग करते थे तो भी यही सर का स्टाइल था. और एक क्वेश्चन जो सबसे फेवरेट उस समय भी पूछा करते थे, व्हाट इज डिफरेंट बिटवीन न्यूक्लियोफिलिसिटी एंड बेसिसिटी. उस समय तो हम लोग डांट भी खाए हुए थे सर से. आज तो खैर आप लोग बच गए हैं. बहुत अच्छा लगा सर. और सबसे इम्पोर्टेंट है कि रिसर्च के साथ साथ जो टीचिंग है वो दोनों सर में मतलब एक्सीलेंट कैटेगरी का है. बहुत कम देखा गया कि जो अच्छे रिसर्चर हो वो अच्छा पढ़ाते हो, लेकिन सर में ये दोनों क्वालिटी है. ही इज अ वेरी गुड टीचर एज वेल एज वेरी गुड रिसर्चर, जिसका आपने अभी देखा भी है. नाउ रिक्वेस्टिंग डॉक्टर सिप्रा फॉर कंटिन्यू द सेशन.
Thank you, sir. Thank you for such an interesting lecture on the basics as well as history of chemistry. It was truly enlightening and inspiring. And we are really blessed that you took time from your busy schedule for being a part of CamWall 2026 and we got a chance to interact with you. सर डॉक्टर अतुल और डॉक्टर सुमित तो आपके स्टूडेंट हैं ही, आज से हम लोग सब भी आपके स्टूडेंट हैं. Now I will request Dr. Sumit and Dr. Bikash to facilitate sir with shawl, plant and memento. Now I will request Dr. Subit to say a few words for sir.
Thank you, Sifra ma'am. Yes. So we recalled our student days as sir was just teaching us, and it is a great pleasure to listen, sir. So we are deeply grateful to Professor Maya Shankar sir for sharing his vast knowledge and rich experience with us. His lecture was not only intellectually stimulating, but also highly relevant, highlighting the vital role of organic chemistry in shaping a healthier and more sustainable environment. On a personal note, I feel especially honored to express my gratitude as he was also my teacher during my graduate and postgraduate studies in chemistry at Banaras Hindu University. At that time, he served not only as excellent educator but also as warden of Bhava Hostel, where I stayed for 2 years. Also witnessed an outstanding teacher as well as a capable administrator. Yesterday, during dinner, he fondly spoke about many of his students who have gone to achieve great success even when their beginning were not very strong. His words continues to inspire us to strive for higher goals and remain committed to our academic and professional journeys. I would also like to extend my heartfelt thanks to the for arranging such a enlightening session, and I think that it is also very much enlightening for participants here too. Once again, thank you, sir, for your invaluable contribution. Thank you. Thank you, sir.
Thank you, Dr. Sumit. Yes, Maya Shankar sir is a true teacher and ocean of knowledge. A big round of applause for him. Everyone, thank you. आप जिनका पोस्टर है वो अपने पोस्टर प्रेजेंटेशन के लिए बाहर चले जाएं. जिनका ओरल सेशन है, we'll continue in this lecture only, means this hall only. पोस्टर इवैल्यूएशन के लिए जजेस हैं डॉक्टर देबा प्रतिम दास फ्रॉम गया कॉलेज, डॉक्टर अकील अहमद फ्रॉम मिर्जा गालिब कॉलेज एंड डॉक्टर सुनील कुमार फ्रॉम जेजे कॉलेज. जिनका पोस्टर प्रेजेंटेशन है वो प्लीज अपने पोस्टर को प्रेजेंट करने के लिए बाहर चले जाएं. The oral sessions will be conducted by Dr. Supriya.
1500 प्रीलोडेड गानों वाला कीपैड फोन धमाकेदार साउंड के साथ कारवा मोबाइल।
कुमारी सिन्हा research scholar by research scholar by chemistry
फैकल्टी में कोई है क्या? फैकल्टी
Thank you.
During periods, extra long days mean leakage. That's why new Stay Free Secure Excel. It's
अंडर में डॉक्टर सर्वर इकबाल गाइड रिसर्च मेरे पास भी पेपर ही है
रमन भी है, तीन नाम आपने लिख रखा है।
इसमें देखिए मैडम 75 से 135 है रिसर्च स्कॉलर मेरा 142 45 है मेरा सीरियल 145 है रिसर्च स्कॉलर
नहीं, रिसर्च स्कॉलर के लिए नहीं है वो, तो खैर 142 से स्टार्ट हुआ आपके फैकल्टी मेंबर्स।
तो इसमें रिसर्च स्कॉलर में मेरा तो है नहीं 142
आपने लिखवा दिया है ना?
जी।
और किसी का है? एनीबॉडी एल्स? पोस्ट का इवैल्यूएशन हो रहा है, मैं कौन एक्सप्लेन और इधर आप लोग प्रेजेंट है आपका? नहीं।
Respected STEM faculty members, distinguished participants, and dear research scholar, a very good afternoon to all of you. It's my privilege to welcome you all once again to the faculty as well as research scholar oral presentation session of this national seminar Game Wall 2026. This session was scheduled from 9:15, but sorry for the delay, and will feature a series of academic presentation by our respected faculty members as well as research scholar listed from 75 to 135 and 142 to 159. The session is coordinated by me and other faculty members. We are deeply honored to all of you. On behalf of the organizing committee, I extend a very warm welcome to all of you once again. May I kindly request all the presenters to adhere strictly to the allotted time of 10 minutes so that every participant gets an opportunity to present actually enriching session. I would like to invite Anil Kumar, Dr.
Whatever something we take from the nature that is not harmful, तो हम लोग ये सोचते हैं कि आयुर्वेदिक मेडिसिन को अगर हम लेते हैं तो उससे कोई हार्म नहीं होता है, और they are from nature and we consume almost all natural products. But what happens? These plants, when are consumed nowadays, this tradition of taking this medicinal plant or herbal is highly increasing, especially after Patanjali के आने के बाद से जो एक नया तरह का जागरण आया है, तो लोग बहुत सारे आयुर्वेदिक प्लांट्स का डे टू डे यूज करने लगे. तो not only in India but we are exporting also. So hundreds and thousands of tons of herbal materials, herbal plant biomasses and medicinal formulations are being exported. So this is becomes now very important that we try to understand that how heavy metal plants are being consumed with the herbal formulation. So we need to, depending upon different region, tropical climate and manures used or sewage sludge, fertilizers, pesticides, how are they affecting the heavy metal uptake by the different plants? Not only when these, due to pollution, they are altering also soil's physico-chemical characteristic. The pH may be changing, organic matter content may be changing, and heavy metals bioavailability may be also changing, and aerosols also, especially near highways. Just soon I came from Gaya to Bodh Gaya, and throughout the highway I observed a lot of dust and a lot of pollution, and this is everywhere actually true. So we therefore require to estimate the heavy metal content. Now, just a little outline: how does how do heavy metals enter into the cycle of different plants? So we can see a lot of industrial products or burnt fuel, fertilizers, pesticides, through air, through soil, through water, they reach to plant, and through plant they finally accumulate in our human body as we consume them. Now also there are different mechanisms where you can see the anthropogenic sources or natural sources, through air, through water, through soil, the root and the leaves and the stem part all are accumulating heavy metal in different content. So we require to study the heavy metal content in these different parts, because they are the different parts of the plants are being used for herbal formulation. Now we can see we are using for different parts of plant for preparation of herbal medicines. So 39% leaf, flower 8%, stem bark 12%, root tuber 12%, root 17%, and whole plant 6% is being used. So a lot of the plant is being consumed. Now the heavy metal. what type of metals we are calling heavy metals. The very simple thumb rule we have, that atomic number if is more than 20 and density if is 5 gram, more than 5 gram per cc, then we are calling that, terming those metals as heavy metals. These heavy metals, if accumulated in in our body, they can cause severe diseases to these different organs. So we therefore require to study this. Now I have listed 14. I'm working on 14, but right now I have report ready for 3. So I'm reporting for 3 right now, for Tulsi, for Brahmi, and for Tagar, that is also known as Jatamansi. So I've used leaf for Tulsi, Brahmi, and Tulsi, Brahmi leaf, and Tagar root is being used. Now, so the materials and methodology. First of all, the materials were collected from local market, local suppliers, and they were washed with deionized water to remove surface contaminant. They were dried at room temperature in dust-free environment, and after that, after drying, I have sieved through to obtain a uniform powder, and the method was to digest the final powder, dried powder. 250 mg of sample was treated with 7 ml of 70% nitric acid and 1 milliliter of 30% H2O in microwave oven. And temperature was programmed for 150 for 10 minutes, 190 degree for 20 minutes, and then held for 10 minutes. Then the sample was diluted for 20 ml with deionized water. An analysis was done using ICP-OS and calibration were done. Now the finding, experimental outcome, region-wise experimental outcome were observed for these three plant species. So cadmium was ranging for Bihar. For contamination level in general was observed to be lower for the Bihar region, higher for the Jharkhand region, and moderate to lower for the Uttarakhand region. Cadmium was observed from less than 0.03 to 0.12 for Bihar. And then for Jharkhand, it was between 0.45 to 3.10. And for Uttarakhand, it was between 0.20 to 2.85 for different samples. And similarly, chromium also ranged low for the low contamination for Bihar region. And it was high for Jharkhand region, and Uttarakhand, it was again moderate. So mercury actually was found below the desired limit actually. So these were the findings, and the result, now the result what was observed have been found that as per the WHO standards, they were exceeding the WHO limit actually. The World Health Organization permissible limit for lead in herbal materials has been found, is actually scaled to 10 milligram per kg. So for lead in Jharkhand region, Tulsi was saying more than 5.2 times actually. Lead for Uttarakhand was found 4.6 times. Cadmium was found 10.3, more than 10.3 times actually. And chromium was also found in Brahmi more than what the limit is. So conclusion is here now that Jharkhand is posing high risk zone, and I think because Jharkhand has a lot of coal-fired power plants and mining operations keeps going on, and also it may be geogenic also because continental crust minerals are available, and agriculture and industrial activities also. Jharkhand has a lot of industries also, so that may be also contaminating. For Uttarakhand region, as we know, Uttarakhand is actually on the folded mountain range. So Himalayan soils have been found acidic, and due to weathering or historical accumulation from natural geological processes. So industrial activities are not that much, but these may be affecting the moderate contamination of different herbal or medicinal plants or their parts. In Bihar, it is in low risk zone, especially the collected samples were from Muzaffarpur around area. So it has been due to alluvial soil composition, they have low background of metal concentration, and regular flood etc. keep coming, so the soil keeps renewing, so that may be also affecting the uptake of heavy metal by the medicinal plants. So final summary is there that we time to time require to do such investigation in different kind of plants or herbal biomasses, because these days tradition we are having more consumption of these herbal biomasses in different formulations, and they are being exported in also in a lot amount. So time to time, routine examination and routine quality monitoring of these medicinal plants are important. And for that, we can have a region specific plan in different regions, how the different other activities may be affecting the increase in heavy metal content in either soil or in water or in air, and that may be affecting the uptake of these heavy metals by these plants. So we can have region specific plan for that, region specific policy for that, to contain the limit of the heavy metals. Thank you, sir.
Thank you, sir, for this insightful and well presented talk. Any question from audience side or from participant?
What do you mean by acidic Himalayan rain? That is. Okay.
Depending upon amount of sulfur, etc. pH is actually little more than little less than 7.
So, any more question? So, thank you, Dr. Mr. Ali. You are currently pursuing. Thank you for coming here and giving your very nice presentation.
The next presenter would be, I would like to invite Dr. Aarti Kumari from Bhagalpur University. So the next presenter would be Dr. Uday Shankar Prasad, a research scholar from Biochemistry, Magad University, Bodh Gaya. Sorry, Uday Shankar Prasad, research scholar from Biochemistry, Magad University, Bodh Gaya.
डिस्चार्ज पूरा लग रहा है, पूरा डिस्चार्ज लगेगा, डायरेक्ट लगा दीजिए, शुरू कीजिए।
Attendance will be marked on the basis of presentation. So kindly आप लोग अपना अपना नाम लिखवा लें। बहुत सारे लोगों ने नाम नहीं लिखवाया है। हाँ, and certificate will be distributed only on the basis of presentation.
Good afternoon, Doctor. Good afternoon, sir, and good afternoon, ma'am. Good afternoon, respected sir and respected ma'am, and my colleagues and PhD scholars. सर मेरा फाइटोकेमिकल इन्वेस्टिगेशन ऑफ कदम्मा न्यू मार्किया कदम्मा जो कि प्लांट इन लाइट ऑफ बायोएक्टिव कंपाउंड पे हमारा है सर। Bioactive compound analysis of alkaloids, flavonoids and other phytochemicals. Phytochemicals जो केमिकल्स हैं, बायोएक्टिव केमिकल्स हैं, उसको फाइटोकेमिकल्स कहते हैं, जो प्लांट्स में मिलते हैं जी। मेडिसिनल प्रॉपर्टी, एंटीऑक्सीडेंट एंड एंटीबैक्टीरियल एक्टिविटी टेस्टिंग किया है सर मैडम सर। ट्रेडिशनल यूज इन आयुर्वेदा एंड मेडिसिन। current state of research and current research gap limited scientific data is available about the chemical properties and uses of Kadamba plant. Insufficient documentation of phytochemical profile.
Go ahead.
Compound need for validation of traditional medicinal claims. Object identify bioactive compounds in the Kadamba plant, assess the antioxidant properties using DPPH method. DPPH method antioxidant properties को टेस्ट करने के लिए यूज करते हैं और evaluate the antibacterial activity of plant extracts. मटेरियल एंड मेथड प्लांट को सर पहले लिया, उसको सुखाया, उसका फूल पत्ता और बार्क को लिया, उसको सुखाया, ड्राई किया, फिर इथेनॉल हेक्सेन और एसीटेट पे उसको लिया। तो एसीटेट पे उसका मतलब ज़्यादा वो फेनोलिक कंपोनेंट्स उसमें मिले। Extraction of phytochemicals, methanol extract shows the highest phytochemical content, rich in phenolics and flavonoids. Antioxidant activity, methanol extract lowest IC value, highest activity. अगर IC वैल्यू किसी का लो होता है तो उसमें एंटीऑक्सीडेंट प्रॉपर्टी ज़्यादा हाई होगा तो एंटीऑक्सीडेंट प्रॉपर्टी कम होगा। Antibacterial are strong against the gram-positive bacteria and moderate against the gram-negative bacteria. High phenolic content and strong antioxidant effect, phytochemical responsible for antimicrobial activity, results support traditional medicinal use. Kadamba is rich source of bioactive compound. Methanol is most effective extraction solvent, potential for pharmaceutical and therapeutical application. जी अच्छा इसका थैंक यू वाला है सर
Thank you, Uday Shankar Prasad. Any question from the participant side? No. I would like to invite next presenter.
Thank you sir, thank you madam for the opportunity.
Ravi sir. I would like to invite our HOD from Botany Department, Dr. Ravi Kumar Singh, to present your work here. Sir, kindly present your work. रवि कुमार सिंह ही लिखते हैं ना। I now invite the next presenter, Sujit Kumar from PG Department of Chemistry, Magad University, Bodh Gaya. ठीक है, आप पढ़िए वैसे ही. शोध पत्र पढ़ने के लिए बोला गया है, वैसा बताया जा रहा है शोध पत्र. तो नेक्स्ट कर देते हैं. जितने भी पार्टिसिपेंट जो पोस्टर के लिए यहाँ प्रेजेंटेशन हॉल में लगाए हैं, जहां भी लगाए हैं, जाकर ग्रुप फोटो करवा लें. पोस्टर प्रेजेंटेशन वाले ओनली. पंकज कुमार टाइगर. I now invite Pankaj Kumar Tiger from Biochemistry to present his work.
Type 2 diabetes mellitus is a chronic metabolic disorder characterized by hyperglycemia, insulin resistance. Yes, sir. Type 2 diabetes mellitus is a chronic metabolic disorder characterized by hyperglycemia, insulin resistance, and impaired insulin secretion. Central role in disease progression. Oxidative stress. Oxidative stress is an imbalance between the production of reactive oxygen species and body antioxidant defense system, leading to cellular and molecular damage. Source of reactive oxygen species: mitochondrial electron transport chain, NADPH, oxidative activity, environmental factor, pollution, smoking, UV radiation, and toxin, inflammation and hyperglycemia. Antioxidant defense system, enzymatic antioxidant, superoxide dismutase, catalase, and glutathione peroxidase. Non-enzymatic antioxidant vitamin C, glutathione. Source of reactive oxygen species in type 2 diabetes mellitus. Persistent hypoglycemia enhance reactive oxygen species production. Mitochondria primary source of reactive oxygen species produced as a byproduct of electron breakdown of fatty acid. Endoplasmic reticulum protein folding error here can release reactive oxygen species. Enzymatic reaction enzyme like NADPH oxidase and xanthine produce ROS for cell signaling or immune effect of oxidative stress. Excess production of reactive oxygen species damage the cellular production of reactive oxygen species overwhelm the function. Lipid peroxidation, reactive oxygen attack membrane lipid, formation of lipid peroxidase, loss of membrane integrity and fluidity, increased permeability and cell damage. Protein oxidation, oxidation of amino acid and amino acid sites and a structural modification of protein, enzyme inactivation and dysfunction, impair cellular process. DNA damage, reactive oxygen species cause single and double strand break, base modification and mutation, impair gene expression and cell function may lead to apoptosis, mitochondrial dysfunction, damage to mitochondrial DNA protein and enzyme, impair electron transport chain, reduce ATP production, energy deficit and cell dysfunction. Inflammation, activation of redox sensitive and transcription factor, increased production of pro-inflammatory cytokine, chronic low-grade inflammation. Insulin resistance, reactive oxygen species interface with insulin signaling pathway, reduce glucose uptake in muscle and adipose tissues. Diabetic complication, retinopathy, vision loss, neuropathy, nerve damage, nephropathy, kidney damage, and cardiovascular disease. Antioxidant defense system, enzymatic antioxidant, superoxide dismutase, convert highly reactive superoxide in hydrogen peroxide, catalase primary located peroxisome, it decomposes and hydrogen peroxide into water and oxygen, glutathione peroxidase reduce and hydrogen peroxide by using glutathione as a reducing agent. Non-enzymatic antioxidant, glutathione, often called the master antioxidant, it maintains cellular redox state. Vitamin C, water soluble, scavenger. Vitamin E, lipid soluble, protects cell membrane from peroxidation. Complication of diabetes mellitus, neuropathy, nerve damage caused by reduced blood flow between oxidative metabolic insult leading to pair of loss of sensation of limb. Retinopathy damage the retina blood vessel leading to vision loss and blindness. Nephropathy damage of kidney filter system, often progression of chronic kidney disease. Cardiovascular disease, increased risk of coronary artery disease, heart attack and heart failure. Peripheral artery disease, reduced blood flow to leg, which can lead to healing wounds and severe cases. Therapeutic assistance, lifestyle modification, dietary intervention and physical activity, antioxidant supplementation, vitamin C and vitamin E coenzyme Q10, natural and herbal bioactive, polyphenol and flavonoids, emerging therapy, gene therapy and stem cells. Oxidative stress play a central role in type 2 diabetes mellitus. Imbalance between reactive oxygen species and antioxidant defense system. A stunting antioxidant defense system help prevent complication. Thank you, sir.
Thank you, Pankaj, for presenting your work at diabetes. The next presenter would be uh, Pankaj Kumar from Biochemistry, Magad University, Bodh Gaya. कौन इसका तो इनऑर्गेनिक ही है ना हेलो वो पीपीटी देख लेना ठीक है ना देखी नहीं हो अच्छे से देख लेना अभी टाइम है अरेंज कर लेना ठीक है कहाँ से हो ये भी लिख दो ना बायोकेमिस्ट्री यहीं से हो रिसर्च स्कॉलर है ना रिसर्च स्कॉलर कैसा रहा पोस्टर प्रेजेंटेशन? बहुत बड़ी बात है। अच्छा, तो 2 लोगों को करना है? 2 लोगों को?
Good afternoon, respected sir and ma'am, and good afternoon, everyone.
All of you are
I am-
requested to please keep quiet.
I am Amit Kumar Suman, a research scholar from Magad University. I am presenting my topic, pyrimidine based heterocyclic molecules, hybrid heterocyclic molecules as potent pharmacological agent. Now, I am introducing about First of all, I'm introducing about pyrimidine. Pyrimidine is 6-member heterocyclic molecules, heterocyclic aromatic molecules, uh, which have 2 nitrogen at first and third position. Uh, it is a several vital structure building block in biological system, including DNA and RNA. Like cytosine, thymine, uracil, and also vitamin B1 have pyrimidine moiety. And pyrimidine containing heterocyclic molecule are very important in medicinal chemistry because of their versatile biological activity and potential for structural modification. Due to this advantage, this scaffold attracted great interest in drug research and designing and development of bioactive compound. This significance of pyrimidine derivative in treating diseases like cancer, infectious disease, and metabolic, and many more. According to the recent development, pyrimidine and its derivative are synthesized along innovative synthesis approaches, such as via Vignelli reaction, metal catalyzed reaction, and microwave reaction. Further, next slide, I will introduce Vignelli reaction. Here is cytosine, uracil, and thymine, and vitamin B1, which all have pyrimidine moiety. Here is some marketed drug which are bioactive, highly bioactive, and this is also FDA approved drug which are already synthesized. This is osimertinib, which is anti-cancer activity, and the second is trimethoprim. It is shown antibacterial activity, and for antifungal activity, here is flucytosine. And the fourth is itravirine. Itravirine is used in antiviral activity, and glipizide is highly active for we all are used for anti-diabetic activities. And the last is busulfanione, which is antipsychotic. Here is some list in which these all drugs are listed here, which all are the status is these all are FDA approved drug which is already synthesized and already patent. This is the reference. Further, I have listed in the last slide these ये जो सारे कंपाउंड है, ये जो सिंथेसाइज किया है वो लास्ट में रेफरेंस में दिया गया है. फिर हम आते हैं जब यहाँ पे सिंथेसिस कैसे किया जाता है. जैसे pyrimidine डेरिवेटिव हम लोग सिंथेसाइज करते हैं, वो बहुत सारे उसका रिएक्शन होते हैं जिसमें हम लोग इसमें बिग्नेली रिएक्शन के द्वारा सिंथेसाइज किया है. बिग्नेली आगे भी नेक्स्ट स्लाइड में हम लोग बिग्नेली रिएक्शन के द्वारा ही अलग अलग कंपाउंड सिंथेसाइज जो किए हैं वो दिखाया गया है. यहाँ पे बिग्नेली रिएक्शन जो होता है इसमें एक एल्डिहाइड, सेकेंड वन इज बीटा कीटो ईस्टर, एंड थर्ड वन इज थायो urea, or we can also use thiourea, and these all are compound are reflux for 2 hours in the presence of HCl and weak, and we हमें ये कंपाउंड मिलता है. तो ये बिग्नेली रिएक्शन के द्वारा 18th सेंचुरी में ये फर्स्ट सिंथेसाइज कंपाउंड है. इसी कंपाउंड से आगे हम लोग फर्दर बहुत सारे रिएक्शन कराते हैं और अलग अलग साइंटिस्ट अलग अलग टाइप के रिएक्शन कराए जो बायोएक्टिव मॉलिक्यूल्स है. Here we discuss about the compound pyrimidine pyrazole hybrid. This is pyrimidine structure and this is pyrazole structure. This compound is synthesized by Johnny et al. In this reaction, here is thioether, and this is beta keto ester, and this is aldehyde. These all are reflux for 6 to 8 hours and in presence of HCl, and the compound pyrimidine derivative is found. Further, this reaction, this is ester compound. This is ester compound. Further, this reaction is present in HCl and NOH. This is hydrolyzed and then make here is acid. Then acid further in presence of SOCl2 के presence में हम लोग रिएक्शन कराते हैं तो फिर ये एसिड जो है एसिड क्लोराइड के रूप में चेंज हो जाता है. फिर ये एसिड क्लोराइड एरोमेटिक एमाइन के रूप में रिएक्शन करवाते हैं के साथ रिएक्शन करवाते हैं तो फिर एरोमेटिक एमाइड यहाँ पे आके जुड़ जाता है. यही कंपाउंड जॉनी इटल के द्वारा सिंथेसिस किया गया जो हाईली बायोएक्टिव है, जिसका यूज कैल्शियम चैनल ब्लॉकर के रूप में किया जाता है. कैल्शियम चैनल ब्लॉकर एज ए ब्लड प्रेशर, हाई ब्लड प्रेशर को लो ब्लड प्रेशर करने के लिए ये कंपाउंड का यूज किया जाता है जो ऑलरेडी सिंथेसाइज है. इन द नेक्स्ट स्लाइड वेंकटेश इट अल हैज उन्होंने ये सिंथेसाइज किया है. ये कंपाउंड जो है 1,3-डाईऑक्सिनो 4,5-डी पिरिमिडीन डेरिवेटिव. इस कंपाउंड में भी हम लोग बिगिनली रिएक्शन के द्वारा ही सिंथेसाइज करेंगे जिसमें 9, 10 और 11 जिसमें है ये beta-keto ester, aldehyde, and this is ether. These all are synthesized. These all are react in the presence of ethyl alcohol and CAN. CAN is steric ammonium nitrate, and reflux it into 20 minutes, and this compound is formed. The compound 12 is also a very highly bioactive compound, and this compound is used for antimicrobial, and this is mechanism of the synthesis of this compound. In the next slide, we will discuss about again Bignelli via Bignelli reaction. We will synthesize the compound dihydropyrimidines, which is 14 via Bignelli reaction. This also we can produce a pyrimidine derivatives, and this is highly also it is highly bioactive compound. Again, this is synthesis of 1, 2, 3, 4 tetrahydropyrimidine 23, which is predicted in 23. This is also pyrimidine derivative, and this is also synthesized via Bignelli reaction. It is also a very highly bioactive compound, and here is the references जहां से हमने ये सारे synthesized compound को लिया है. ये सारी references है. And thank you for everyone for listening. Thank you, sir. Thank you, ma'am.
Now pausing the session for the oral presentation and inviting Dr. Ravi Kumar Singh, HOD, Department of Botany, Magad University, Bodh Gaya. He is postdoc from Swedish University of Agriculture Science, Uppsala, Sweden, and he gained his PhD from IISER, Kolkata, in the field of plant and microbial genomics with Max Planck Institute of Chemical Ecology, Jena, Germany. And he did MTech from bioinformatics from JNU. He awarded several awards. In some of them are postdoctoral fellowship from Carl Kreiser Foundation, Sweden, and he recently awarded by UGC BSR Research, which is a startup grant. He published several papers in Springer, Nature, elsewhere, and Oxford University Press. So inviting Dr. Ravi Kumar Singh for his invited lecture.
laptop. Very good morning. Thanks, Sumit. Uh, so, let me know actually, have you heard about this term CRISPR-Cas? I hope most of you have heard or not? Yes. So tell me, how many you have idea about the CRISPR-Cas? Means what is CRISPR-Cas and what it do actually? Anyway, so of course I have chosen this topic, CRISPR-Cas system. So exactly the genomic editing tool, right? So there are so many different tools are available for the genetic engineering or so-called, but this one is the most promising genomic editing tool. So it is genome editing tool, right? Earlier there were several, like recombinant technology, most for us RNA interference. So even when we are doing PhD, so we have used the technique RNA interference for the all the genetic engineers. But now in 2014, the mechanism was discovered. What is the CRISPR-Cas and how it works actually? So after that, and it is a precise genome editing system, very fine, right? The most positive things about this is it edit at the genome level. So here RNA interference, it works at the RNA level, not genome level. So means anything that is going to edit, that perpetuates for the generation. This is the beauty for the CRISPR-Cas. So I am not going to detail about the CRISPR-Cas system, but here are the something different that I think it will be easy for me to communicate you the biology, why and how. So it is genome that going to be edited, right? So genome is, everyone know that is the inside the nucleus, and this is a chromosome, and here chromosome there is a DNA. That is the actually going to generation and move or pass the information. So this is the central dogma of molecular biology. So means the information that is coded inside the DNA, right, that passes to the protein through the RNA, right? And means what information is there inside the DNA actually that express and that functionally work at the proteins, right? So what will be the protein? What will the function of protein actually? That decided by the DNA. Or DNA means it is, if you look at the DNA, so it is a polynucleotide. So if you look at the details of the polynucleotide, okay, you will find only there are 4 different types of repeating units, that is monomers. So symbol is the ATGC, right? So whether it is genome of the bacteria, fungi, plant, animal, only these 4 different letters actually represent the whole genome. right? So just think about this is the language of genomic language that is dependent on only 4 different letters. Think about the English language, right? They only 26 alphabet, 6 letter. So this 26 letter actually communicate the half of the world actually. And when Hargobind Khurana, right, deciphered the genetic code, means how the information embedded inside the gene, actually DNA, that passing through the RNA to the proteins, this is only the distribution of this 4 letter. And they deciphered the complete dictionary. Means there are only 64 different codons, out of the 3 are the stop and 61 is the genetic code. So means they disclose the complete dictionary of DNA language, right? Complete dictionary of DNA language. So if one has over command over the English language, so it will be very great, right? Just imagine DNA has the only 4 letter through which the whole dictionary is completed. Right. This is the only 4 letter actually. This is about the arrangement distribution of this 4 letter over the length of the genome that is guiding or controlling our whole phenotypes or the physical or say the whole body actually. Right. So and but when we got this is actually sequence how this is coded, but at the mechanism level, the only the distribution of sequence, the residue that actually guide also the conformation of the protein, right? 3D protein. So when you look at the function of protein, it is not only the sequence, the configuration, 3-dimensional configuration actually what this adopt, it will be important for the function, right? And the structure actually not the configuration actually not guided by the only the sequence. That is also the environment, microenvironment, the pH, temperature, the system of the system, right? But the entirely ultimately the what will be the type of protein actually the what is the structure that depends upon the distribution of the amino acid that is guided by the distribution of nucleotide, right? So just this is the example that how this sequence of DNA actually got translated in the form of the protein, the peptide. And this is the whole genetic code on which this total the scenario is going on. Right? This is discovered by the Hargobind Khurana and team. So if see how this actually happened. So this is the genetic code is stipulate, and once I got the open reading frame, so which triplet code is coding which amino acids, right? We got the protein sequence by the referencing of the genetic code. And if there is a particular changes, a particular site, it will change the proteins. And but the changes actually also depends at which position going to happen. The first position, or second position, third position. So there are primarily 2 types of mutation of change going to happen inside the DNA. The substitution means one nucleotide going to substitute with another one, and another is insertion or deletions. So means there are either regions once nucleotides got deleted or once either region one got inserted at particular positions. So the whole phenotype of the protein got changed due to the mutation. Right. So there are in nature this mutation going to always happen. Right. Even if you find 2 different the same protein having different function, there are merely differences at particular positions. Right. This is the actually beauty of this protein actually. So what actually this CRISPR actually system do? Let's see what is the CRISPR system actually. So as I told, it is a genetic tool, editing tool, which the edit the loci, genetic loci. So it has 2 actually. The Cas protein, which is coded by genes, and there are repeating units, repeating sequence of the RNA that called a spacer. Actually, CRISPR-Cas system actually it is natural part. You may say the hallmark of the bacterial prokaryotic system. Bacteria has naturally embedded the Cas system in their genome. This is the actually Cas is the acquired immunity for the bacteria. So it is not reported in the eukaryotic system, no, in the prokaryote. But see how we are utilizing the prokaryotic system for the generative in the eukaryotic system, right? So this is the naturally present in the bacteria system. And there are three basic steps through which the Cas work actually, right? So allow the integration of DNA, sort the desired target. So the a segment through which we want to edit or insert, right? Based on that, actually, it synthesizes RNA that is called the CRISPR RNA, and this RNA actually guide the Cas protein to target the site and the cut down. This is the basic mechanism that is the same mechanism for the RNA interference. Though all the endonuclease genes actually protein do actually. This is the same basic principle that followed by the CRISPR-Cas system. And this actually system actually used as a technology to target or edit the desired site or desired loci at the genome and for the modification of under modification as per our requirement. That is the actually that is being used for the different purposes. So now here, what actually here CRISPR will do, right? So let's say that anyhow this mutation got happened or the peptide got changed actually. So this actually changed at our genome level that is going to perpetuate through the generation, right? So what CRISPR-Cas actually use and to correct those mutation insertion. So means CRISPR use this sequence, the original sequence, and again reinsert this sequence to the genome, native genome, so that it get corrected through the genome level. CRISPR-Cas system, right? This is the actual question. So now, based on this potential application, actually, there have been many fields, actually, agriculture, biotechnology, medicines, things are being going, and people are using this technology for the improvement of the trade and the disease recovery of the diseases, actually, different types. So even agriculture, it has been largely being used for the different purposes: genetic improvement, biomass production, nutrient use efficiency, enhanced physiological traits, particularly to the response for the stresses, to cope with the stresses. So, and this is the some milestone that have been achieved through the Cas-CRISPR system. So means you may see the actually gluten-free wheat and non-allergic apples. That what we achieved through the CRISPR-Cas technology. So this is the actual application for the CRISPR-Cas. But here actually I want to point some different things. Okay, this is fine. The high potential CRISPR-Cas is a very big potential for all the applications. But bacteria has not only single type of CRISPR. Bacteria have different types of CRISPR. What we are using is a single one we are using. So see, bacteria naturally has CRISPR system their genome. We don't have. And what we are using only the one technology we are using, but bacteria has different system. So what we are using only this one, Cas9, the single proteins. This technology CRISPR, what we are using, that has only synthesize a single protein, Cas9. That is around the 1200 amino acid length actually. But there are other system bacteria that has having that different systems. And still the mechanism, the complete application are still need to be discovered for this all system actually. Right? So and just imagine we are using the Cas technology of the bacteria for our purposes for the development. And just imagine what bacteria we are doing. Of course, bacteria naturally they are having. So doesn't mean that they are not using. Definitely they are using their system for their own purposes. Right? So I think the life cycle of bacteria is around half an hour, right? A bacteria get multiplied within half an hour, right? And if you look at the genome of the standard bacteria, 700 or 800 genes are there that complete the genome, right? Complete genome. Maximum around the thousands genes are there that code for the protein. But thing is that bacteria has clustered, right? Genomes are. We had in eukaryote, each and every gene has their own promoter and regulators, but bacteria has clustered. So it sometimes become tricky for all the techniques and tools what we are having for the detection of genes on the genome. So this is the major problem. Even the number of this Cas system becoming increasing day to day. So there are, if you look at the different bacteria hierarchy, the same bacteria, maximum 13 Cas system has reported in particular bacterial species. So means, in other word, I can say or may say that bacteria has more robust or strong gene editing system than what we know and what we have actually. Bacteria is more having more robust system and different robust system, right? See and also if you look at this is the Cas6, different subunit of the Cas6 E, F, and 5. See how the different actually. If you look at this active site, so structure is almost same, sequence is same, but they have just minor difference at the active site through which they target the different sites actually. So I am saying through this actually presentation, what we are knowing about the Cas9 is a single one, but bacteria has much. And in that way, actually, bacteria is competing or advancing more than what we know actually. Right? Bacteria is advancing more. So how specific CRISPR is really concerns about CRISPR especially led to new methods for detection and avoidance. And of course, it doesn't mean bacteria. Okay, CRISPR has success rate is around 50-60%. But what about the 40%? Means we have not complete idea, knowledge about the mechanism of the CRISPR. But still, out of the available all the genetic editing tool, CRISPR-1 is the most promising, for which we are actually doing. And that's what I'm saying. This is the means 50-60% success is there. But why not 40%? Why will not complete? Because this is off-target effect. Means the specificity of the target, the position of the gene where it's going to target. And this is the number of publications that we have in the first the CRISPR-Cas mechanism was disclosed in the 2014, and that after that this technology had been using by different, and till now I think today morning I checked around 39,000 citations within the last 10 years. Actually, it's recorded when used. So bacteria and archaea have evolved sophisticated adaptive immune system known as CRISPR-Cas system, which target and inactivate the invading viruses and plasmids, right? And the evolution of CRISPR-Cas loci involves rapid changes. In particular, numerous rearrangements of the locus architecture and horizontal transfer of the complete loci or individual others. This conserved mechanism, the Cas system actually, guided adaptive immunity in the bacteria and archaea, enable them to withstand and evolve the changing environment. So yesterday also we have heard about how the changing environment actually favoring the evolution of bacteria and viruses more than the plant and animals. Means bacteria and fungi and viruses are evolving more than us in this changing environment actually. Right? So it is a very famous quote when Louis Pasteur has said, "Gentlemen, it is the microbes who will have the last word." Means on this earth, the last world will be the world of bacteria. Right? So why? This is one example, because bacteria have their natural CRISPR-Cas system in their genome. Thanks for this time.
Thank you, sir, for this insightful and informative session. This was really nice. If anyone has any question, then you may please ask. Anyone question from the audience side, from the participant side? You may ask.
Hybrid वो सब GM brinjal and BT cotton.
BT cotton.
There was a controversy.
What is BT cotton? That is generated with the RNA.
That was genetically
but not success actually. But this is actually CRISPR-Cas. That people are using that going to be success because you target of tracking the genome, and they are not going to affect the effects of genome. researchers across the world are using the CRISPR-Cas. Even some labs have banned the RNAi and the other place. Right? Because if you ask you to point out the BT protein and the danger, so there are lots of negative effects due to the RNA. But there is very less or means there is no report for the negative aspect of the CRISPR-Cas. That's what people are suggesting or using the CRISPR-Cas rather than the RNAi and the other.
Thank you, sir. So one more question.
Yes.
On your last point, sir, if bacteria, microbes will have the last one. What about viruses? Are they more advanced or they are primitive?
But the viruses are not living. They are the connected in between the living and living.
So they are advanced systems or primitive systems?
No, I am not. I can't answer because see, one person is saying that some viruses are developed origin from the our genome. Some viruses develop from the bacterial genome. Right. So even I have not much heard or read about the answer to this question because viruses are actually circular. Right.
Because they can tolerate heat, they can tolerate
Actually,
everything.
even vegetables are highly mutable. So let's say I give you a particular site. Right. I just giving an answer. Right. See the genome sequence. We have same, bacteria same. Viruses are also.
Please keep quiet.
RNA.
All of you are requested.
Right. But even in the a particular site tissue may change, mutate. But do you know how many mutations can be allowed for a particular position? Right. So what data suggests that viruses can frequently change the position than the bacteria and viruses and the other higher eukaryotes. So it is very tough or practically very tricky to check or to estimate the origin of viruses. Okay, let's say COVID-19. There is one alpha and beta different strains. They are more niche because of that. But after 1 year, if you check the strain of that COVID-19 viruses, the today it will be different, entirely different. So it will be very tricky to answer or very tough to answer that question about what is the origin of the viruses on the in context of this bacterial. But yes, what the bacteria has potential in terms of this genomic architecture, Luis Pasteur rightly said, means the last word on this what will be the bacteria.
Thank you, sir.
Thank you, sir. With this, we conclude the session. The next session will be scheduled from 2:30 p.m. onwards, and we will proceed to the lunch now. लंच के बाद हम लोग मिलते हैं इसी सभागार में.